In the mid-20th century, the world of structural engineering was grappling with a massive bottleneck: the sheer math required to predict how the Earth behaves under a building. Nathan Newmark, a giant in the field at the University of Illinois, realized that while Boussinesque's equations for soil stress were mathematically beautiful, they were a nightmare to apply to the messy, irregular shapes of real-world foundations. In 1942, he unveiled a solution that was as much a work of art as it was a calculation tool: the Newmark influence chart, decoding the circular web. If you've ever looked at one of these charts, it looks like a strange, hypnotic target or a spider web gone rogue. It consists of a series of concentric circles divided by radial lines, creating a grid of units. The genius lay in its simplicity. Each small segment on that chart represents the exact same influence or contribution to the vertical stress at a specific depth. By overlaying a scale drawing of a foundation onto this grid, engineers could simply count the squares covered by the footing to find the answer. The power of the influence value. At the heart of this tool is the influence value, IV. When Newmark designed the standard chart, he typically divided it into 200 units, meaning each segment represented a 0.005 fraction of the total applied pressure. This allowed engineers to bypass the calculus and use a straightforward arithmetic approach. Whether you were dealing with an L-shaped warehouse or a circular grain silo, the chart didn't care about the geometry. It only cared about the count. The math behind the magic. To find the vertical stress, sigma sub z, at a specific depth, z, below a corner or point of interest, Newmark's method utilizes a clean, proportional relationship. In a world before pocket calculators, this formula was a lifeline for geotechnical precision. During the height of its use in the mid-century United States, this method was the gold standard for American infrastructure. Engineers would work with loads in pounds per square foot, PSF, or kips per square foot, KSF, scaling their foundation drawings so that the depth Z equaled the unit length AB printed on the chart. If you wanted to know the stress 20 feet down, you simply set your scale so that 20 feet matched the chart's reference line, traced your footing, and started counting. From paper to pixels. While we've largely traded our tracing paper for finite element analysis and sophisticated software today, Newmark's influence chart remains a staple of engineering education. It teaches a fundamental lesson in discretization, the idea that complex, continuous problems can be broken down into manageable, equal parts. Nathan Newmark didn't just give us a way to calculate stress. He gave us a visual language for understanding how the heavy weight of our world filters down into the dirt beneath our feet.